Hi, and welcome to Experience Points by University XP. On Experience Points, we explore different ways we can learn from games. I'm your host, Dave Ang from Games-Based Learning by University XP. Find out more by going to universityxp.com. On today's episode, we'll answer the question, what is the game state? Determining the game state is often one of the questions that designers and developers will ask themselves when determining how to take a design or iterate on the development of a game. The game state is important to understand from a design perspective, but what role does understanding the game state play for educators, instructors, and trainers using games-based learning? This episode will define what we mean by game state from multiple different perspectives. It will discuss different characteristics and types of game states and the roles that they play for commercial and applied games. Game states often are tightly related to the game rules and mechanics. These two aspects will be discussed in depth in addition to other tangible elements of gameplay such as game objects, movement, and environmental states. Game states also refer to game and player progression, which are often reflected in mission and character development. These aspects are inevitably linked to time and events in games. These two elements can have different impacts based on digital versus tabletop games. Therefore, the two will be discussed as they relate to the relationship between game states and players. Players often relate to the changes of game states through some kind of narrative or storytelling function. These will be discussed as well as how these transitions are linked to the changes in game states through the conclusion of the game with win states and fail states. For applied games, these are inevitably linked to learning states and learning outcomes for individuals. Ultimately, game states relate most closely with the player experience and changes in player states throughout play. These are most closely related to how players interact with the game. For certain games, this interaction can come through a third-party character such as a dungeon master for tabletop role-playing games. Otherwise, the interaction could come through non-player characters that serve as avatars for interaction throughout the game. Finally, this episode will close on the best application of game states for game designers, as well as how understanding the game state aids in the application of games-based learning. For the purposes of this episode, we'll define game state as the current snapshot or state of a game and all the relevant information and data that pertains to it. This could include a huge amount of information, but for the purposes of this discussion, it'll focus on the condition and progress of the player and the game at a specific moment. Understanding the game state is crucial for designing and developing games to function as intended, as well as providing an engaging and consistent experience for players. Game engines for digital games provide programming frameworks for managing the game state. These are often reflected in save points, checkpoints, and events as they are handled by the game engine. Likewise, tabletop games must rely on players themselves or the game master to determine, augment, and arbitrate different changes in the game state. Game states for games-based learning rely on these critical in-game events and activities, but go one step further in assessing the progress, challenges, and outcomes of the player. This is important to include as the purpose of both applied games and games-based learning is to aid learners in meeting predetermined learning outcomes. Therefore, the game state aids educators, instructors, and trainers in determining how the game has progressed to help players achieve these goals. Feedback from the game state thus allows these individuals to adapt game mechanics and content accordingly. From a serious game development perspective, understanding the game state is important because it aids developers in creating effective interactive learning experiences that holistically blends game mechanics and educational content. Doing so aids educators and end users in monitoring and adapting games to ensure players progress towards the achievement of learning outcomes. There are certain characteristics that are associated with game states. This directly ties into the different types of game states as they relate to the player experience. For digital games, the game state is decided largely by a machine state or status in which components, actions, resources, and environment are evaluated as generated by the game or the game's intelligence. Many modern digital games that are shipped with artificial intelligence representing everything from third-party non-player characters to cooperative teammates to competitive opponents use these machine states as decision controllers for determining what happens next in gameplay. This is where we examine the game state as a sequence of states that are most recognized by players themselves. They are usually delineated by a series and combination of visual, audio, and animation cues in digital games. Therefore, when discussing the game state in relation to the player experience, we can focus on three separate and distinct areas: the early game state, the middle game state, and the late game state. The early game state usually focuses on player orientation and onboarding. Here, players determine how they can and choose to interact and engage with the game and establish base-level competencies for them to excel through gameplay. A good example of this is in Super Mario Bros. For the NES Level 1-1, which provides opportunities for the player to use all of the actions in the game that are necessary to complete it. The middle game state is where players are offered all or most of the game mechanics available to them in the game. Here is where a player builds on their previously established competencies and discovers or develops other avenues, tactics, and strategies for implementing their agency in the game and progressing through it. It is important for game designers to coax and support players from the early game to mid-game in order to continue their player journey towards achieving higher-level competencies throughout play. Not all games have a late game state, but those that do offer challenges that test players' competencies throughout their early and mid-game plays. This provides opportunities to continually engage more advanced players throughout play, as well as sets them up to assess their abilities. The latter is most important for serious games, applied games, and games-based learning, as the late game is most closely tied to the summative assessment for stated learning outcomes attached to serious game designs. The game state is most often connected to the formal elements of game design, one of which is the core gameplay loop, game mechanics, and rules. Therefore, it's important to determine how and when these different formal elements interact with one another and how that interaction informs and sets the game state. Game rules affect the game state due to the possible orientation, quality, and possession of different game resources. This is more critical for digital games that rely on physics engines to represent objects in space and time. Most tabletop games don't need to address this, but game mechanics and rules affect how certain actions are prioritized and resolved when progressing through play. Game rules and mechanics are closely related. However, there is a distinct difference between game rules and game mechanics. The difference is that game mechanics are focused more on the interaction with the game state and changing its properties and balance, whereas game rules provide the means and situations where interaction is possible. Therefore, game rules can be modeled after agency, what players can do in the game. Conversely, game mechanics are modeled for agency, what players actually do in the game. Often the focus of game designers and developers is on game mechanics which players utilize in games. These mechanics are set up to provide players with the agency to overcome challenges set forth by the designer. By doing so, the game state transitions into a new state. Therefore, it can be said that game designers create the basic mechanics of the game as the central elements for traversing the basic challenges of the game. This gives game designers great power in defining and curating the player experience for them. But they are not the only agents responsible for doing so. Other individuals working with a game designer, such as writers and producers, work with smaller tasks that affect and influence the player experience and the game state itself with story, theme, and user interfaces. One of the most common considerations for examining and studying the game state is the status and positioning of different objects in the game environment, the movement of objects, player characters, and non-player characters, as well as other environmental considerations. These aspects are important to consider as they represent interactive elements of many games and are subject to change as the game progresses. One of the most common game resources or elements that are considered here are game currencies. Currencies can serve multiple different formats for games, but all represent a way to limit, measure, or otherwise provide agency and a locus of control of the player in relationship to the game environment. That's because the economy of the game's formal structures can be designed to provide players agency and self-determination as it relates to the game's limitations. Likewise, these currencies can occupy either tangible or intangible properties inside of games. Those physical properties often represent themselves in inventory of players, as different currencies may take up space as it relates to the maximum allotment to a player's storage. Conversely, currencies that are used to facilitate economic transactions in games such as gold or other commodities may or may not take up actual space and may instead be used strictly as counters or tallies. The storage, use, and consumption of these resources speaks to the movement of them within the game environment and thus changing the game state. Movement also affects environmental elements as well as player and non-player characters that can take actions within the game world such as walking, running, or interacting with other characters, resources, or objects. The means and methods from which these characters interact between and with each other are often dictated by thematic elements of the game. Those often include the time period, background, geography, and climate. Some games go to great lengths to describe or produce these elements for player consumption, whereas other games, such as tabletop RPGs, rely on the descriptions of a dungeon master or the imaginations of the players themselves. Examination of the game state falls specifically under this type of world building, as the layout, terrain, and geography present in the game world can reflect different statuses such as explored, unlocked, or hidden. The status of these different elements can change given how players move or are transported in the game world. Such transportation can be player-driven or can include in-game transportation systems. No matter how movement is accomplished in a game, it is almost always dictated by players' choices and activities. Sometimes these choices fall under the domain and purview of a single player. Whereas in multiplayer games, the same kind of information can be shared between users. This kind of movement or relational data often includes information such as the position, status, and actions of other players in the given session. One important consideration for these other player elements in massive multiplayer online games is that of player collisions or intersections between characters and other characters, the environment or objects. Therefore, determining how these disparate elements can interact with each other are often part of the formal structure for how these games operate and thus contribute to the status of the game state. The status, location, and direction of objects, characters, and environments in games most closely go hand in hand with the main progression elements of games. Those are often included in mission and progress states. These states determine and provide feedback to players based on how far the player has advanced in the game. Often these include various levels of achievement such as completed areas, points earned, or quests accomplished. Games may even include formal elements which categorize and document how players have improved in their own skills or knowledge acquisition, a feature critical for reflection in games-based learning. The status of quests and missions in games is important for determining the whole timeline for the completion of these formal elements. This often includes a comprehensive list of all that is necessary to complete the quest, what has been completed so far, and what remains to be done. This is often necessarily reflected in player profiles, which indicate players' scores, achievement, and progression in the games. All these characteristics, in addition to unlocked levels, character abilities, and possession and status of player equipment, affect and influence the game state. These characteristics are important to consider from two perspectives. First, from a player experience perspective, as it is often important for players to determine the process of progression and achievement throughout the game. The second comes from formal events in the game space are often dependent on others' players' states and progression. Therefore, accurately tracking the player progression, acquisition or resources, and consumption of resources is critical. Game mechanics are often designed and created to help players produce or consume said resources. As such, these resource transactions are often closely tied to different times and events in game states. One of the most common elements for consideration in discussing game states for digital games are those of timing and events. This is because actions taken in games at a granular digital level are based on scripts that often trigger automations or responses from the game due to players' behaviors. This usually occurs within a timeline of other events determined from the game design. These game scripts are usually tightly connected with the overall design of the game. Players interact and engage with these scripts through narrative or storytelling conventions. These can be transparent and overt or based on in-depth themes and connections between the overall environment and game mechanics. However, these scripted events are not limited to only digital games. Tabletop games have their own form of scripting that are disseminated to players via formal rules. However, the arbitration of these scripts is based on the actions and agency of players themselves. Game states also rely on the timeline of different events as related to main compared to side quests, the latter representing auxiliary goals and objectives for players to attempt and accomplish based on the overall narrative of the game. These alternative and parallel goals are used in both commercial games as well as serious games and simulations, as they can be more easily tied to summative and formative assessments. Lastly, both checkpoints and save points also represent different timing and events related to the game state. This is especially relevant for digital games as the state of the game at that moment is saved. Therefore, players can return and continue their progress later. These points often relate to the overall storytelling and narratives as they are represented in games. Storytelling and narrative conventions also relate to the state of games. These are often present in many but not all games. However, they are most prominent as a way of blending disparate formal game elements such as mechanics with the overall theme of the game. This can be seen in how different objects are chosen within the game to represent different formal elements such as resources and non-player characters. However, objects are not the only thematic considerations for storytelling and narrative game states. Rather, other aspects related to world building, such as religion and politics, help inform and connect gameplay to the game's overall theme. If done well, these can be integrated into the formal rule set of games, which aid in player immersion and player experience. Storytelling and narrative design can go even further with defining the game state for players by communicating more about the thematic elements of the game through the choice and arrangement of different objects in the game world. These are often observed when describing the larger thematic elements and setting of games such as post-apocalyptic environments that we witness in titles such as Fallout and Mad Max, as well as exotic locations and long-lost cultures in games like Sleeping Gods. One element that is often included in open-world digital games that aid in world building are the use of cultural artifacts, such as photos and journals, that share a narrative perspective from other non-player characters in the game, the results of which provide opportunities for additional storytelling, details, and thematic minutiae that cannot be easily added via broader strokes of world building. While not all games require the use of in-depth storytelling and narrative conventions, they do overall aid in better and more holistically connecting formal game elements to the theme and purpose of the game. This can be seen when they are integrated into player goals, which maintain overall individual motivation, engagement, and desire to progress. Perhaps the most memorable game states for players are the liminal ones. These are the situations where players are in a state of transition, often to an endgame state such as with win, loss, or fail states. But this doesn't encompass all the states that players can find themselves in. Players can also engage in different learning states, especially through games-based learning. These transitions between states, often called a state of liminality, is important to consider as players continue in their player journey throughout the game. Perhaps the easiest way to think about this kind of liminality is the change in sequence of states where each new state is defined by a series of events which create a new game state. One of the most common of these terminal states is the win state, particularly for tabletop games where the pursuit of the win state is what ends the game and determines the victor. However, these aren't the most important states to consider, especially with games-based learning, as the iterative process of the experiential learning cycle is emphasized through the provision of loss and fail states. These fail states are important for experiential learning as a way of providing feedback to learners that they have not met all the expectations for a goal, objective, quest, or activity in a game. Therefore, instructors and educators can use these game fail states through debriefing in helping learners determine what they can change to improve in the next iterative cycle of their play. Fail states are very powerful motivators for examining what has gone wrong and how players can improve from it. They can be very gentle and endearing with the help of an empathetic instructor or educator, or they can be brutal or demanding, as seen with many roguelike games where players must restart the game from the beginning, thus losing all of their progress. These fail states are not binary, though. Fine-tuning of how and what feedback players receive as part of failure in the game is at the heart of applied games and simulations. This is perhaps where the magic circle of games-based learning and simulations is most critical. That's because these forums allow learners to take risks in these spaces where they are calculated and real-world consequences are lowered. This feature aids in players' abilities to exercise their full agency in the game, the result of which is the provision of adequate learning states where individuals are free to play, experiment, and test their theories and abilities within the game to model the learning they gain from it more accurately. The transition between these different types of game states, as well as how the player sees and perceives them, directly influences the player's experience. Great focus is usually placed on this experience as it directly addresses motivation and engagement. This is especially true for learning and educational games, as a demonstration of player progress is critical to encourage them to continue learning throughout their play. Therefore, the game state from the player perspective is largely determined by their own expectations, how much they expect to progress, how much success they expect, their chances of success, and what they hope to discover. These expectations are then reconciled through the formal element of games as they are compared against the player's intentions, the results of which are the foundations of the emotional experience of players and how the game reacts to their agency and input. This means that the game's state can be interpreted in multiple different ways based on the perspective of the viewer. From a player perspective, it represents how emotional connections are made to the game and reconciled against how much of their agency is supported by the formal game elements. From the designer and developer perspective, the game state for the player often represents specific objective functions such as positioning, direction, and the status of different objects within the game world. However, no matter how the player experience is examined within the game, it's important to note the kind of roles that other non-player characters and third parties, such as game masters, can have on the impact and interpretation of the overall experience. Much of the game state in digital games are handled by the game's engine, which takes care of all of the tedious elements related to tracking the location and status of game components, resources, and other environmental characteristics. However, this is not always possible for tabletop games. Tabletop games sometimes require an arbiter or third party that officiates, manages, and otherwise mediates the differences in the game state and how they relate to players' experiences overall. This person is often called the game master or dungeon master. For tabletop role-playing games, this could even include statistical information about both players' characters as well as non-player characters controlled by said game master. In this role, the game master controls and determines the state of the game and all of the components, players, and environmental considerations within it. In addition, the game master also makes logic-based decisions on the game as they apply the game rules and update status changes and other elements of environmental differences as the game progresses, all of which affect and influence changes in the game state. These game masters have a storied history, some of which goes back to the earliest applications of war games and simulations for teaching and learning with the advent of the Kriegspiel. Here, umpires would unify game rules, resolve dice mechanisms, and overall simulate the game world. They would report the game state and relay that information to players. These are all important elements for maintaining the integrity of the game world. However, some digital games go further with the introduction of non-player characters who often serve varied functions. NPCs can be used to provide story, thematic, or narrative information for the players. They can also serve as formal game elements through bartering, trading, and selling functions. They can aid in the form of tutorials and active guides throughout certain processes of the game. Lastly, they can also represent opponents and adversaries for active players to engage and surmount. No matter what role these NPCs play, they often form realized version of formal game elements through the use and application of thematic game components, which further aid in player immersion and interaction. It is much easier for players to relate to a bard singing tales of the player character's quest than a dialogue box which can provide the same information, while dungeon masters, game masters, and NPCs often serve underappreciated functions in games. Their presence, application, and influence of the player experience aids in the overall immersion and integration of the game state in the game world. Game states have various applications for players, but are most critically examined by game designers. Game designers and developers rely on the evaluation of the game state to support formal game elements, the economy and operation of the game, as well as serving the overall player experience. Therefore, game designers often work by maintaining and updating the game's state through various mechanical elements. Those are often observed in how player decisions are reflected in the core feedback loop. They can also be seen in mission and quest progress and how it is reflected for players. In addition, challenges and objectives are reflected in the game state that support overall player engagement. The latter is most often evaluated through constant, consistent, and thorough iterative playtesting, which is used to determine how players interpret their interactions with the game and how they progress through play. Therefore, game designers' interactions with the game state can usually be surmised by determining if the game-produced outcome was expected, welcomed, and integrated by players. This episode has examined game states from the perspective of the players, game designers, and developers. However, considering the impact of the game state is also important for educators, instructors, practitioners of games-based learning, and the greater applied games community. Therefore, it's important to consider how the game state influences and affects how games are used for teaching, learning, training, education, and development, and how they influence these outcomes. There are 5 major areas in which the game state affects applied games. They include learning objectives, challenges and difficulty, adaptability, feedback, and data and assessment. Applied games for teaching and learning often reference educational games, learning games, and serious games. These games are mainly designed with learning objectives and educational outcomes in mind. Instructors and educators who know about and are aware of the changes of the game state can determine how in-game progress and objectives measure against the player's experience and evaluate individuals' performance in meeting stated learning outcomes. These outcomes often encompass players' abilities to solve problems as well as applying newly acquired knowledge. In addition, it's important to consider how challenges and difficulties for players change and inform the game state. This is especially important for educators working with small cohorts of students, as it allows them to fine-tune the level of difficulty for players to maximize their engagement and motivation. Doing so ensures that the game is neither too easy nor too difficult. Either case causes the game to lose its educational value and otherwise frustrates or bore learners. This further informs the adaptable nature of games in the hands of experienced applied games educators. Knowing the status of the game state allows them to make further adaptations and changes to maintain learner engagement. Doing so can be as granular as providing additional support in accomplishing tasks within the game, as well as making broader strokes such as promoting active debriefing in the post-play process to help learners ascertain outcomes on their own. Such attention paid to the game state by educators also furthers their goals in providing accurate feedback to learners, as well as aiding in the assessment of learning initiatives. Educators should note that academic assessment can take on many forms. Specific games-based assessments are often realized in formal components of games such as scores, progress bars, leaderboards, and detailed player performance analytics. While these detailed data-driven reports are not necessary for all learning, a dedication to this kind of granular assessment can help educators determine what data is important to collect and how that data can be interpreted and reported to more accurately assess learning achievement. Lastly, this addresses the need for overall assessment of learners, the game environment through the game state, as well as the outcomes of play. Such data can be used to evaluate a games-based learning project overall, as well as aiding educators in making informed and applicable decisions about augmenting a course, class, curriculum, or program of its games-based elements. Doing so ensures the effectiveness of games-based learning overall. This episode addressed the concept of the game state. The game state was defined and were addressed through different characteristics as well as different types of games. Game mechanics and rules were discussed as they relate to and inform the game state. Specific elements of game state functions in digital games were discussed. Those included object, movement, and environmental states, and how they represent different trackable elements of the game state. Tracking was also an important part of the player experience through the update of missions and game progress in the game state, both connected with time and events in game states that are critical for tracking in digital games. These aspects were most relevant to object, character, and environmental positions when addressing changes in a physical environment represented in a digital game. However, not all game state functions relate directly to objective elements within games. Storytelling and narratives also play critical roles in determining game states and can serve critical functions for how players interpret and interact with formal elements of games. Those interactions often resolve themselves in transitions and changes through liminality. Those come about through the resolution of games in win, fail, and the requisite applied learning states. As players move throughout these different phases in the game, they often realize these different changes and adapt and interpret them accordingly. Therefore, the player experience and changes in the player state are wholly connected to changes in the game state. These are often realized through the arbitration and intervention of third-party characters in games. For tabletop games, these can often be game masters and dungeon masters, whereas for other applications, these interventions can come through non-player characters. This episode concluded with game states as they are addressed from the perspective of game designers, developers, and games-based learning practitioners. The aspect of the game state is a critical one. However, their relevance, usefulness, and applicability ranges based on the roles of designers, players, learners, and instructors. I hope you found this episode useful. If you'd like to learn more, then a great place to start is with my free course on gamification. You can sign up for it at universityxp.com/gamification. You can also get a full transcript of this episode, including links to references in the description or show notes. Thanks for joining me. Again, I'm your host, Dave Bang from Game-Based Learning by University XP. On Experience Points, we explore different ways we can learn from games. If you like this episode, please consider commenting, sharing, and subscribing. Subscribing is absolutely free and ensures that you'll get the next episode of Experience Points delivered directly to you. I'd also love it if you took some time to rate the show. I live to lift others with learning, so if you found this episode useful, consider sharing it with someone who could also benefit. Also, make sure to visit University XP online at universityxp.com. University XP is also on Twitter at university_XP and on Facebook and LinkedIn as University XP. Also, feel free to email me anytime. My email address is dave@universityxp.com. Game on.